Next thing we're going to talk about is writing variables in simplest form. For example 7, I've got the fifth root of 4, a to the 8th power, b to the 14th power, and c to the 5th power. So again, same steps as last time. We're going to try to take the fifth root of 4. You should know that we can't take the fifth root of 4. So the 4 will stay underneath the radical. You cannot take the fifth root of it. Now as we move on to our variables, 5 goes into 8 one time. So 1a will come out. But there will be 3 left over. 5 goes into 8 one time with 3 left over. So the ones that are left over stay underneath the radical, a cubed. 5 goes into 14 two times. So 2 of them will come out as b squared. 5 goes into 14 two times with 4 left over. So b to the 4th will stay underneath the radical. 5 goes into 5 one time. So 1c will come out. There are none left over, so there is nothing that will go underneath the radical. Your final answer will be a b squared c, the fifth root of 4a cubed b4. Example 8. The fourth root of 48, a to the 11th power, b to the 4th power, c to the 13th power. All right, we cannot take the fourth root of 48, but we also can't leave it that way. 48 needs to be simplified. 48 breaks into 16 times 3. Again, you can look at these factors and see if either one of them have a perfect fourth root. 16 actually does have a perfect fourth root. The fourth root of 16 is 2, so the 2 will come out, and what's left under the radical is the 3. Fourth root of a to the 11th power. 4 goes into 11 two times. So I'll have a squared that comes out with 3 left over. The ones that are left over stay underneath the radical. 4 goes into 4 one time, so 1b comes out. It does not have any that remain, so there's nothing left to put under the radical as far as b is concerned. 4 goes into 13 3 times, so c cubed comes out, and there's 1 left over. So your final answer, I'm going to write it again because that's kind of sloppy. 2a squared b c cubed times the fourth root of 3a cubed c. I just rewrote it. Don't let that confuse you.